1.2 part 1. Basically, we're going to spend some time reviewing domain and range. Okay, that's going to be our big focus here. You've seen domain and range. We discussed domain and range in Algebra 2 last year. Okay, but domain and range also carries back to Algebra 1, maybe even before. So, a few definitions here. Function. A function from a set D to a set R is a rule that assigns each element in D to a unique element in R. Keep in mind, D and R are going to stand for
X and Y's.
Domain and range.
Domain and range.
We'll get to that. But what we're saying here is a function. It's a rule that assigns each element in the domain to an element in the range. And the key word there is to a unique element. So if you remember talking about this, one of the ways to determine if something is a function is making sure the domain does not repeat, because we want the domain to, each domain goes to a unique range value. Okay? So the way we also say that is that the domain values cannot repeat. Logan already said it. Domain are the x's, okay? We also talked about the domain being the input, okay? What's coming into the function? The x's. Range are the y's, or in other words, the output. The x's come into the function does its job, the output is the y's, the range. Now, one of the things we're going to talk about is something a function? Easiest way to check and see if something's a function? You guys remember the vertical line test?
Yeah, kind of.
No.
Okay.
You gotta have like two lines if it like touches a line or something.
Well, vertical line test, if you draw a vertical line, and in order for a graph to pass the vertical line test, a graph can only touch a vertical line in one spot. So as many vertical lines as you draw, each vertical line can only touch the graph once. If you draw a vertical line and it goes through the graph in more than one spot, it's not going to be a function. Okay? That's the easiest way. If you have a list of x values, you could look and see if any of the domain values repeat, but easiest way is to look at the graph. Now, this kind of jumps ahead to example 3, but one of the big topics we're going to spend a lot of time on this lesson is finding domain. Okay? When we talk about domain, remember domain are your x's. X's run which way on a graph? X's run left and right, yes?
Right.
So when we talk about domain, we're talking about how far left does your graph go? How far right does your graph go? Okay, a few pieces of information. All polynomials. Okay, so that's things like your parabolas, your cubics, your quartics, where it's just terms, just regular terms with positive integers added. They'll have infinite domains, negative infinity to positive infinity. Key pieces that we'll talk about, denominators can never equal 0. So if you get a denominator, a value where the denominator equals 0, that's going to become something like an asymptote or a whole. Okay, we'll talk about that. The inside of a square root. What can we not take the square root of in real number land? We can't take the square root of a negative. So the inside of a square root must always be greater than or equal to 0, or that's a fancy way for saying positive. Okay? And then another good way to find domain is just reading the graph left to right. Okay, so if you have the graph, looking at it from left to right. When I teach domain, I like to put it all together. I like us to look at the equation, look at the denominator, look for any square roots, but I also like us to read the graph. And we'll practice doing all of this together. Okay? So, before we get to domain, which is down on example 3 though, let's talk about whether a couple of these are functions. Is y equals x squared a function?
What equals?
Is y equals x squared a function?
Yes.
Okay, what's your reasoning?
Well, because that's just a parabola at 0, 0, and it's never gonna touch a vertical line more than once.
Okay, so if you think about y equals x squared, I expect you to know at this level that y equals x squared is a parabola. And we'll talk about that in lesson 1.3, some graphs I expect you to recognize. But that's a parabola, yes? Vertical line test, the idea with the vertical line test is if I draw a vertical line, it only touches my graph once. If I draw this vertical line, it only touches my graph once. If I draw a vertical line over here, it touches it once. Can I draw a vertical line that touches the graph more than once?
Try, but it's not vertical.
Okay, it can't happen. So right there, there is one reason that, yes, we know it's a function. Another option is to think about an XY chart. Okay, another option is to think about an XY chart. If I put in -2 for x, what is y? If I put -2 in for x, what is my y value?
Oh.
-2 times -2 is 4. So 4. What about if I put in -1?
1.
1. If I put in 0?
0.
If I put in 1? And if I put in 2? Now, with each of those x values, when I put in 2, can I get another y value besides 4? You put in 2, you get one output there, right? That's the idea of a function. As I look at my x values, okay, I don't have one x value pairing with 2 different y values. One x value goes with each y value. Now, I had some repeats in my range, but that's okay. It's just no repeats in the domain. So, I agree. Yes, that one is a function. Okay. Example 2. You have 3 graphs to look at, yes? And on example 2, the question is, which of the following is not a function?
Third one.
Agree? Disagree?
I agree
Why?
because it goes through x's twice.
Okay. If I draw a vertical line here, that vertical line crosses through this graph once, twice, 3 times. So for that one is not a function. What about the first 2? Do they pass the vertical line test?
Mm-hmm.
They do, don't they? I can draw vertical lines. They're never going to touch the graph more than once. Okay? You remember the vertical line test at all?
Yes.
Okay, it's an easy one. You just have to remember how it works. So this one fails the vertical line test. Okay. We're going to go ahead and start talking a little bit about domain. Obviously, we'll have to talk a lot about domain tomorrow, and we'll talk range. But when we talk domain, up above, there were 4 pieces here, yes? And really, it's 2, 3, and 4 that we're going to focus on. But those are the things we're going to use to help us investigate domain. Key things. Denominators can never equal 0. Inside the square root must always be positive. And then we'll practice reading the graph. As we look at example A here, what do you see based on what we just talked about? There's a square root, yes? What do we say about a square root?
It's gonna be positive.
It's got to be positive, right? So think about what's under this square root, x plus 3. When I say that has to be positive, I mean that has to be greater than or equal to 0. Is that equivalent or true statement?
Yes.
If whatever's under the square root has to be positive to take the square root, it has to be greater than or equal to 0. What do you get when you solve this?
Less than 0.
-3.
X is greater than,
If it's x plus 3 greater than or equal to 0, subtract 3 over and x is greater than or equal to -3. Okay, guys, that's your domain. How do I write that in interval notation?
negative, or parenthesis, bracket, -3,
To infinity.
comma, infinity, parenthesis.
So if the domain, what we're saying is this graph exists when x is greater than or equal to -3. So where's my graph going to start at? -3. Why did we decide to use a bracket? Equal to. How far is my graph going to go according to this? Infinity. Okay, so this is the domain I would look at. Now, the other piece I put up there was to read the graph left to right, yes?
Yes.
So graph this real quick.
Done.
On your calculator, graph y equals the square root of x plus 3.
I don't like it. Kind of goes like this.
Sideways
Yeah.
half parabola.
Sideways back.
Half parabola. It's not
Yeah.
full parabola.
It's basically a graph.
No, it's not full.
It's not. It's half.
It's half of a parabola, it's only the positive half.
Oh!
P Money, P Diddy, P Dodgy.
Okay, guys.
Wrong. That's what I thought.
Real quick,
Stunned.
does this graph agree with the answer we just put on the screen?
It do.
It does.
Okay. Because I'm going to argue we could have just looked at the graph.
Yeah.
Okay. I want you guys to be well-rounded. There are times where I need you to be able to just look at the graph and figure out the answer. There's times I need you to be able to just look at the equation and figure out the answer. But if you look at this, what we did in Algebra 2 last year at the beginning of the year, when we talked about domain, I said, okay, start from the left. If I start from the left, where does my graph begin?
-3.
And it begins at -3, yes? You could trace that and figure it out. Does it touch -3? It does. Again, you can trace it, you can check your zeros, figure that out. How far does it go?
Infinity.
Infinitely right. So just like in Algebra 2, we said 3 to infinity. We're also trying to look at, though, understanding how to use this equation here. Okay? So if I graph this for us real quick, just to have a graph here. It's the idea that my graph goes from here over. So as the first time my graph exists is at the x value -3. And then it exists to infinity. Okay? That's a little bit about what we'll do with domain. Obviously, we didn't get to a denominator question. We'll talk about B tomorrow.
Hey, be kind.
The homework is obviously